Professor Ajayan Vinu, the University of Newcastle, Australia. Good afternoon.
Good afternoon.
Would you talk about your contribution to the chemical sector?
Yeah. See, I have been in this field for the last 25 years, and we have developed a series of advanced nanostructures with a different chemical composition. And in fact, we are the first one who discovered nanoporous carbon nitride materials, nanoporous boron nitride and boron carbon nitride material, nanoporous fullerene, and in nanoporous biomolecules. And these materials have a unique physicochemical characteristics, including the tunable band caps and very high surface area and large pore volume and uniform pore size distribution, and with a very high surface area. And these properties make them available for various applications, for absorption, separation, and catalysis, sensing, and even drug delivery. So what we have been trying to do is to develop the material that can help the society and the world. And one of the key discovery that we have made, and that made a huge impact to the society, is the splitting seawater into hydrogen by using visible sunlight. And it was a dream of every scientist in the world to split seawater into hydrogen by using a sunlight. People failed. The reason is because of its alkalinity and also the catalyst that will be corroded so quickly. But the catalyst that I have developed, which we have just filed a patent, can split the water into hydrogen under visible light with a solar to hydrogen conversion efficiency of almost 3. And this is the groundbreaking discovery, and this is going to change the world. When I say it is going to change the world, the reason is quite simple. Because to produce a hydrogen, to produce 1 kg of hydrogen, you need a 10 liters of water, right? But even the industries in India trying to use electrolysis method to split water. But for that, you need a high purity water, right? So in the world, we have a 330 million cubic miles of water. In that, 97% is a seawater. Only 3% is in the form of normal water. Among this 3%, only 0.3% is in the form of surface water, lake water, river water, and underground water. If we started to use that water to produce hydrogen, then you are creating another social problem. So to solve the global warming issue, you need a hydrogen for sure. But from where you will produce hydrogen? With the water. From where the water will come from? Nobody knows. But the only way to solve the global warming is to generate hydrogen from seawater using easily available sunlight. So that's what we have discovered.
So, at what stage is this technology?
Yes. So currently we are in technology readiness level 4. So we had a discussion with the Reliance Industries, and we signed the NDA to commercialize that technology. But since it is in a TRL 4, and we have signed an NDA with them, and they said that, okay, bring it to TRL 6 and make a pilot plant, and then we will, move it forward. So we had a wonderful discussion with Professor Mashelka, who was quite excited by this technology, because it was a groundbreaking, and it was a dream of every photocatalytic scientist, because it is going to change the world. Hopefully, if we can translate that into TRL 6 or TRL 7, and maybe in 2 or 3 years' time, and we will have a hydrogen from the seawater. That is really, really needed. You know why? Because the CO2 level in the atmosphere now is 430 ppm, and it is mainly coming from the fossil fuels. 2021 alone, we have liberated 36.5 billion tons of CO2. And at that time, the population is less than 8 billion, right? Now the population is, around 8 billion, and we consume 530 exajoules of energy. 1 exajoule is 1 billion tons joule, right? And where this energy is coming from? Fossil fuels. and that liberate huge quantity of the CO2, and that is, making a huge changes to the earth in the form of the global warming. And you see the global warming is causing the melting of glaciers and flooding in Kerala, Tamil Nadu, Japan, and we are losing a lot of people and drought everywhere. I mean, unless otherwise we find a solution for the global warming, the earth is going to be destroyed. So it is all our responsibility to find a solution for this global warming. And splitting of seawater into hydrogen is the only solution and cleanest solution with the sunlight, with the cleanest solution that can provide the clean energy solution to the world.
So what are the things that you need to do to reach to TRL6?
Funding. So we got the funding from the Australian government to make the lab scale, but then we made now 1 meter by 1 meter. But what we like to have is a 30 meter by 30 meter. Because, my dear friend, see, it's not only production of the hydrogen, but we need to show the TRL6 or TRL7, the pilot plant of hydrogen production. But once you produce hydrogen, what you are going to do with the produced hydrogen? We have to connect that hydrogen with the fuel cell. And the fuel cell generate energy. That energy should be stored somewhere. Then you need a battery. So the integration of all these technologies required if you really wanted to make it, commercially viable. So it's not a small thing, it's a big thing. So we have to have the support of industry partners to translate this exciting discovery into a real, the commercial technology that will benefit the society and the world.
Technology is future technologies which will make an impact in the Indian chemical sector.
Yeah, this is one of the technology that I am talking about. The reason is that it can not only provide clean hydrogen or a clean energy to the world, but also you can use the produced hydrogen for the production of steel, green steel, and for production of pharmaceutical products, fine chemicals, right? And conversion of the CO2 into clean fuel. And then copper and aluminum smelting companies, that produces a lot of CO2, but you can use this hydrogen as a clean fuel. Another interesting thing here is that, like a solar cell, you can put this hydrogen production facility in every household roof, and they can use the produced hydrogen for the cooking and heating and everything. See, don't you think that it is a revolutionary? And this is the technology that I am talking about. But with the support of the industry people, maybe the Reliance or Adani or something, and we can speed up that commercialization of this technology.
So when you take seawater, one has to do reverse osmosis and then make it clean, and then it is used by the industry. Do you see its usage also in the industry by using sunlight and the technology that you are talking about for the industry?
Absolutely. See, for the electrolysis, people are using the seawater, but to convert that seawater into normal water, you need a 3.3 times more of seawater, right? And to produce 1 kg of hydrogen, and that you need 55 kilowatt hour energy. And that's a huge energy if you wanted to achieve 530 million tons of hydrogen in 2050, right? It's a large amount of energy. The amount of hydrogen that is needed. But through this sunlight assisted process, and you can get this one just with a simple visible light splitting. And your question is that, do we need to separate that salt from the seawater? No. So my technology is quite unique. The presence of the salt is the key to improve the performance of that material for producing hydrogen. So we tested that water collected from different beaches using our material, and it works very, very well, right? And the another beauty of our the nano material is that once the alkali metal ions are absorbed in your system, and once, I mean, after few cycles, and you can easily remove it, right? And then reuse that material again and again and again. And that's the beauty of our technology.
So what is this technology called?
So it's a sunlight assisted seawater splitting technology for the production of hydrogen.